Hello everyone, welcome to the Spintangle. This is a new session on mathematical physics. Today I will be discussing on differential equations from mathematical physics, and I will give a series of systematic lectures on the entire syllabus of mathematical physics for different competitive examinations. So let's start with differential equation and first understand what is a differential equation. A differential equation is a mathematical relation, let me write it, containing derivatives. Say you have applied force on some object. Say this is a object and you have applied force from this way, force. And from the second law of Newton, we know that whenever we apply force on any object, then what happened? There acquires mass, and the force becomes what? F is equals to m times area. M is what? M is the mass of the body. Okay, this means what we can conclude from this fact that F equals ma. Okay, say for spring systems, I am giving an example of this fact. Okay, this is an example. Say for spring systems, what we know, F is equals to minus kx. What is F here? F is the restoring force. As this is a kind of, as this F is a kind of force, therefore this F can be replaced by ma is equals to minus kx. This means what? We can write this as A is equals to k upon m x, and from this we can take this k by m as omega square and the x remains x. This is what is the acceleration of the mass. Okay, say a spring system, or say a pendulum system. This is not the differential equation, this is the equation of acceleration. Okay, as this equation does not contains any differential terms, that means d dx or d2 dx2, say d2 dy2, okay, or dy dx, derivative with respect to y. Therefore this is not a differential equation, this is just a representation of the acceleration in terms of angular frequency and the position, instantaneous position. Okay, then this is omega square, this is x. Now we know acceleration is the time derivative of velocity. This means what we can say that dv dt becomes equals to minus omega square x. And also we know that velocity is what? Velocity is the difference in displacement upon difference in time. That means what we can put here, ddt is dx upon dt is equals to minus omega square x. So what we can do from here, that d2x upon dt2 becomes minus omega square x. Now it is a good looking differential equation. Okay, differential equation. Okay, that means from this what we can do, we this is just an idea of the fact that what is a differential equation. Now the differential equation could be of this form also, dx upon dt is equals to anything, say x plus y. Okay, anything that contains derivative in the general formulation is called a differential equation. Differential equation is why it is important. Why it is important? It is important because if we solve this differential equation, if we solve this differential equation, then we get the equation of the position. Okay, equation of the position. In mechanics, this equation is sometimes called that the equation of motion. Equation of motion. So equation of motion in mechanics is a differential equation. In quantum mechanics, what we can say? In quantum mechanics, we know the Schrodinger equation is given by minus h square upon 2m d2 psi upon dx2 plus v psi is equals to e psi. This is also a differential equation. Okay, this is also a differential equation. By solving this differential equation, what we will get? We get psi. Okay, the required wave function that represents the wave of a corresponding particle. Okay, this is the wave function. So this is the importance of differential equation. It makes the system easier in terms of mathematical representations. Okay, this is nothing but a mathematical representation which just makes easy the system. Okay, we have to solve the equation and then we have to obtain these things. Okay, there are various types of differential equations. Let's discuss. Okay, say if you have a differential equation in which there was a term called dy by dx. This is, I am discussing the order and degree of the differential equation. Order and degree, you can make a heading on this. Order and degree. Say dy dx, in a differential equation is equals to, say, ax plus b. Okay, this is a differential equation. This is a differential equation of first order and first degree. Because why first order? Why first order? Because there is only a differential term which is the first derivative of the y with respect to x. If this is a first derivative, then it is called the order. Okay, say in a equation it is given that d2y by dx2 and so on, and the other terms are there, then this will be called as a second order differential equation. Okay, now what is degree? This was the order. Previously this was the order. Now we are discussing degree. What is degree? Degree is, it is the power of highest order term in the differential equation. Okay, this is what we call a differential equation, and here is the degree and order. Say, for an example, say an example. I am writing an example for just only for understanding purpose. This means, say, let me change the ink first. Let me select a dark ink. Say d2f upon dx2 plus df upon dx plus n into n plus 2 into f is equals to 0 and give a total power of 2. Okay, then what is the order of this? Order is what? Order is the maximum derivative present. Okay, maximum derivative present. You can see here, you have a second order derivative in the first term and a first order derivative in the second term and a zeroth order derivative in the last term. It is written as this. Okay, so what is the maximum order here? This is the maximum order. Okay, this is the second derivative. Second derivative is present maximum. Okay, then therefore the highest, what is the highest order? The order will be 2, because here the second order derivative is the maximum derivative. Okay. And what is degree here? Okay, just wait for a while. Then what is degree here? I have written it in earlier that degree is the power of highest order derivative. Power of highest order derivative. Here what is the highest order? Here highest order is this term, the first term. Then the what is the power of this term? The power is 2 here. The power is 2 here. These 2, and here you can see the power of this is also 1. Okay, it is also a differential term, but not the maximum order differential term. Here the maximum order differential term corresponds to second. Okay, second order differential, and the power of the second order differential is what? 2. Then what will be the degree here? The degree will be 2. Okay, what is the degree here? It is the degree. This is the order and degree of a differential equation. Please comment below. I am giving a problem related to this fact. This is comment on the comment box that what is the degree and power of the this differential equation. Say d2y by dx2 plus y dy by dx plus n into n plus 1 y is equals to 0. Okay, this is the please comment on the comment below section. Okay, Okay, what is linear differential equation? Now the another point is, what is linear differential equations? Okay, linear and an ordinary, called here an ordinary differential equation. What is a linear ordinary differential equation? Linear ordinary differential equation says that all derivatives should have power is equals to what? Is equals to 1. This means you do not have any term like this, let's say d2y by dx2 to the power say 3. This is not linear, this is non-linear. Why it is called non-linear? I think you peoples know about the fact that y is equals to mx plus c, this linear, I am just justifying this fact of why it is called a non-linear. It is not linear, it is not linear because here is a cubic term present. Okay, this is a equation of a straight line. Say what is a straight line? Say straight line. This is a equation of a straight line, and this is a equation y is equals to say 4x square. Okay, this is the equation of parabola. You can see easily that in this case the power of y is what? The power of y is 1, the power of x is also 1. In this case the power of y is what? 1, and also the power of x is what here? 2. This 2 makes the graph non-linear. This is not linear. Non-linear. Linear means not line. Okay, this is linear because it is a line. Line from linear, this is line r. This is non-linear and this is non-linear and the upper one is linear. From this idea the term comes that what is a non-linear differential equation. Say I am giving an example, non-linear differential equation. Non-linear differential equation means there is no power. Okay, say dy by dx, a equation contains dy by dx is dy by dx to the power 3, say dy by d2y by dx2 to the power 5, say d3y upon dx3 is say 2. These are all terms which reflects in the fact that the differential equation becomes non-linear. So in case of linear differential equation, let me write, the equation has to contain the terms like these, say dy by dx, say d2y by dx2, say d3y, sorry this is not plus, d3y by dx3. Okay, as these terms does not contains any power, so this will be called as linear differential equations. As you have seen in the above equation that this term in this term we can see that the power of x is 2, This means this becomes non-linear. Okay, in this here is a power 1, here is a power 1, here is a power 1. This means this reflects in the fact of linear differential equation. Linear differential equation. Okay, and our focus will be on this. Our focus will be on this fact that we will be discussing on. We will be discussing on this linear differential equation. Okay, this is in our syllabus. Okay, I think non-linear and linear is clear to you. Now go back to the point that what is homogeneous differential equation and non-homogeneous differential equation. Homogeneous and non-homogeneous. What is a homogeneous and non-homogeneous? Okay, let me clear it. Say, and please give me an example. Say there is a differential equation example. These are mathematical terminologies, and they will not be clearly understandable if we do not have any example. Okay, say d2y by dx2 plus 2xy dxy dx plus suppose log x plus 9. Suppose this is a differential equation. Okay, now let me write something. What is a you can check this fact by this, that if here is 0, if here is 0, okay, if here is 0, you can easily say that this is a homogeneous differential equation. And if there is no 0, then you can easily say that this is a non-homogeneous. Okay, say function of x. In case of there is a term containing function of x, then you can say this is a non-homogeneous. It is, you have to check this, non-homogeneous. Okay, okay, say in this example you can check it from this example that d2y by dx2 plus 2xy dy by dx plus put this log x on the either side, log x. Okay, here what you can see from this, you can see easily from this, this is a term, this is a function of x, function of x. What is function of x here? Because log x containing the term x, log x containing the variable x. This means easily we can conclude from this fact that this is a non-homogeneous equation, non-homogeneous differential equation. Okay, is it a linear or linear or is it a linear or non-linear differential? It is non-homogeneous. I can easily say that this is a non-homogeneous because the either side, in this either side you can say there is a function of x term. And from our previous topic that we have did linear and non-linear linear and non-linear differential equation, we have learned about this fact that what was the fact that d2y or dx2 doesn't have any power, 2 or 3 or 4 5 doesn't have any power. Okay, and this term you can see easily this thing that the first term, the very first term of this differential equation has power 1. In the second term you can easily see that the power is 1. This means this is a linear, this is a linear differential equation. Therefore, the entire name of this the differential equation goes very big. Okay, what is the entire name? I have to write this: linear non-homogeneous. You can write in your own way: non-homogeneous ordinary. This is an ordinary differential equation. Differential, you may omit this, okay. Ordinary differential equation, because all of the differential equations you encounter will be given as ordinary differential equation. There is no special differential equations you will be given. Okay, this way what we can write from this equation, that this is a very big name, and we people are too much lazy in this fact that we do not want to write this entire name. This is a very big name. Therefore, what we can write here: linear non-homogeneous ordinary differential equation. Okay, you can write it like this for your understanding perspective. Okay, in the comment box say I am giving the question 2 for the comment box. In the comment box you please comment that I am giving a differential equation, whether what is the nature of this differential equation: linear or non-linear, non-homogeneous or homogeneous. Okay, let take d2y by dx2 to the power 3 plus 5xy dy by dx plus cos x equals to 0. Write down the nature of this differential equation. What is the nature? It will not come to your examinations, but it is for your understanding purpose only. Okay, what is the nature of this differential equation, of this ordinary differential equation? Okay, please write down below. Okay, this is the differential equation. Okay, the differential equation, the first part of this differential equation has been recorded and I will be submitting on the YouTube channel, and a second part will also come. Okay,